Hello and welcome to the Introduction to Blockchain on Azure. This talk will cover the following, starting with what is blockchain, then moving into how blockchain technology works, talking about different blockchain types, and when to use blockchain. I'll start by telling you a little bit about myself. My name is Meaghan Lewis, and I'm a senior program manager at Microsoft. I am part of the Microsoft Reactors team, and what I do on that team is focus on creating and delivering learning experiences centered around emerging technology for our reactors worldwide. So I have a really fun job where I am fortunate enough to have time to learn and explore and create and go out and speak to technologists all around the world. I am currently focused on blockchain. This has been a big interest of mine since I've joined Microsoft. I'm also starting to focus my attention now on Rust and Go programming languages. I have a passion for teaching lifelong learners and have spent over half my career speaking at conferences, giving talks, delivering online courses and workshops. And I live in the San Francisco Bay Area where I've lived for the past decade with my husband and our 2 dogs. I am going to be covering the Introduction to Blockchain on Azure Learn module today. So to follow along and to check out this Learn module on your own, you can follow this link. That's aka.ms/intro-to-blockchain-8. So there you can find the blockchain module that I'm going to cover in this presentation. You'll also notice that this is part of a learning path about getting started with blockchain development for the Ethereum platform. So my hope is that after this session, after this talk, you can go and explore the other content available in that learning path. All right, so what is blockchain? Blockchain is a record-keeping and contract enforcement technology that's based on complex cryptography. It allows organizations to streamline shared work streams, such as supply chains, by exchanging and tracking assets and transactions on a shared ledger, built with what's called distributed ledger technology. Blockchain networks are distributed among all the participants' computers, giving everyone real-time visibility into every transaction that occurs on the network. Each participant can reject incorrect or invalid transactions before they're applied to the ledger, which simplifies auditing and greatly reduces the risk of fraud. Blockchain technology was popularized by the cryptocurrency Bitcoin, and today developers are driving new revenue streams by creating blockchain-based apps and services across nearly every industry. A common question that comes up as folks are considering whether or not to use blockchain-based apps and solutions is why not use a regular database? So let's talk through, the differences between a regular database and using blockchain as a distributed ledger solution. So why not use a regular database? Throughout this talk, I am going to be referencing an example of an ice cream factory. And even with this ice cream factory, there are many folks that are involved in this business. So I'm going to be referring back to this example throughout the talk. So let's go ahead and start by talking about this example as it relates to centralized databases. So we could use a centralized database that all participants here, you have the farm, you have the shipping companies, you have the factory, you have the ice cream store. So we could use a centralized database that all of these participants use to track shipments. In many scenarios, a centralized database is probably the right solution. But suppose we have a centralized database that stores details about the shipment and who's currently responsible. In our scenario, we could have a farmer, shipper, factory, and retailer all use the same database. The advantage of this is that it's easy to control access and consistency. Everyone is using the same database and there's a trusted authority controlling access. But there is only one database, so all participants are using the same set of data. All participants need to trust the database is correct, and by extension, they need to trust the owner of the database not to modify the historical data for whatever reason. So what if our scenario doesn't allow for a trusted central authority? What if no one company wants to be responsible for hosting that centralized database? Perhaps the requirements for system integration with each participant can't be met. So let's look at the example of perhaps we could use a distributed database in this ice cream scenario. So what if each participant could have their own copy of the database? A distributed database is going to use multiple copies of a database, and changes are then going to be synchronized across the different copies. In our scenario, we could have the farmer, shipper, factory, and retailer use their own distributed database. The advantage of this is that each participant does have a copy. In most cases, it's easy to control access and integrate your systems and process in your own copy of a database. However, synchronization of changes to each database is required, so handling failures and conflicts can add complexity and data integrity issues. And now let's look at finally the example of the distributed ledger. So I mentioned that blockchain technology is referred to as a distributed ledger. And just like an accounting ledger, the distributed ledger is a history of transactions. Each transaction in the ledger affects the final state. Blockchain networks that are distributed among participants are called a consortium network. And that consortium network gives each partner visibility into every transaction that occurs in the network. Blockchain uses consensus rules to ensure that data is consistent across nodes. It also uses cryptography to enable participants to trust the data. And specifically, it prevents any individual participant from modifying history or modifying records in this database. So in our example, we have a requirement to support multiple companies with no central authority due to cost control or being a single point of failure. So in this scenario, a distributed ledger would work best. Now that we know the basics of blockchain and the distributed ledger technology that blockchain is built off, let's see how it works behind the scenes. This information should help you decide whether blockchain will work for your scenario. So in our scenario, there are multiple companies again, and you see that illustrated here. There's Contoso West Shipping, Contoso East Shipping, Dahlia Paleo Farms, the ice cream shop, and the ice cream factory. Each participant has a copy of the blockchain ledger, and each participant also represents a node. Looking at this illustration, you can see that there isn't a requirement for each company to have their own node. For example, if you look at Contoso eShipping and shipping, you can note that nodes might be shared between partners. Each node, however, is connected to other nodes using a blockchain network. So for example, Dahlia Paleo Farms and the ice cream shops each have a node that they manage. There doesn't need to be a one-to-one relationship of nodes to companies. Now let's talk about changing state. Data in a blockchain represents state and ownership. Blockchain uses transactions to change the state of the data from one value to another. For example, we need to know if the ice cream is stored below freezing. So in a shipment of ice cream, a temperature sensor reads the temperature periodically. The reported temperature is a transaction that is sent to a blockchain transaction node. In the ice cream scenario, when a shipment is sent through the supply chain, a transaction is sent each time the status changes. And the illustration shows transactions for a typical shipment to the ice cream factory. Each transaction changes either the responsibility or the temperature. The current state of the ledger is the transaction applied in order. So when sending a transaction, you send it to a blockchain transaction node. Let's suppose Dahlia Paleo Farms sends a shipment of milk using Contoso West Shipping. Dahlia Paleo Farms shipment system sends a transaction to their blockchain node, and the transaction updates the shipment responsibility from the farmer to Contoso West Shipping. Blockchain is able to send the transaction throughout the blockchain network. Each node gets a copy of the transaction, then each node processes this transaction, but it still requires validation using a consensus mechanism. Consensus enables consistency and trust for the distributed ledger. In a distributed network, it's difficult to determine what is true because data changes must occur across all nodes. What happens if the ice cream factory node doesn't get a shipping transaction? How would they know if the milk has been shipped from the farm? What if the shipping company's refrigeration truck fails and the milk spoils? Could the shipping company modify their ledger to avoid responsibility? So all of these are questions that might come up in this scenario where you're dealing with multiple participants in this system. Blockchain uses a consensus mechanism to validate and agree on the data across all blockchain nodes. And consensus is going to provide a way for all decentralized nodes to come to the same state. So when transferring value or responsibility, order matters. For example, if you transfer ownership of a car to your friend, you can't also transfer ownership to a teammate. This issue is known as the double spend problem, which consensus solves. Consensus assures the correct order of transactions and the integrity of the blockchain. As part of consensus, a group of transactions is validated as a block, and the network must agree if the block should be included in the blockchain or not. And the main consensus algorithm used today is called proof of work. So proof of work is commonly used for public blockchains like Bitcoin and Ethereum. And I'll get into that a little bit later in this talk. Now let's talk about what is a block. So a block is a cluster of data within the blockchain that has both a unique identifier, a hash, and a history. Blocks store transaction information such as date, time, or dollar amounts, as well as the signature of the transaction participants. So if you look at this block, for example, I see it has a number of transactions. These transactions include change of responsibility as well as change of temperature. So it's important to note that a block can have multiple transactions. It will always have at least one, but depending on the different network, it's possible for there to be up to thousands of transactions within the single block. And you'll notice that each block has a specific number that identifies it. In this illustration, you see that's 0. There is also a unique hash which identifies this particular block. A great place to see blocks from different blockchain ledgers is to go to blockchain.com/explorer. There you can see the latest blocks and transactions from different cryptocurrencies like Bitcoin and Ethereum. This is very useful at being able to see blocks all the way from the beginning of time on these blockchain ledgers and get a really good idea as to what information goes into a typical block, seeing all the metadata and all of the other transaction data that's included in part of that. Now let's talk a little bit more about blocks and how they help to make the ledger immutable or not changeable. So blockchain uses a cryptographic hash to create a link between blocks. By linking blocks, the order of transactions can be agreed upon through a consensus algorithm. And a cryptographic hash is an algorithm that maps data of an arbitrary size input into a bit representation of fixed size output. You can almost think of it as a digital fingerprint. And Bitcoin uses the SHA-256 hash algorithm. So if you used a SHA-256 hash function on a 100-page document, the function output is a 256-bit hash value. And no matter what input that you give, the output is always going to be some unique 256-bit hash value. If you change just one character in that 100-page document, the hash would be regenerated, and you would get end result a different 256-bit hash value. Now imagine if we use a block as the input to the hash function. The output is going to be another 256-bit unique hash for the data in the block. So blockchain uses these hash values to detect if any changes have been made to the blocks. By including the previous block's hash value when generating the next block's hash, blocks are chained together through hashes. Blockchain provides trust by using hashes to prove data history hasn't changed. By including the hash of the previous block when creating a new block, an immutable chain of transactions is created in order. If any block is modified in the chain, the hash of later blocks is different. And this is really what makes blockchain so secure. Blockchain allows us to store data that is consistent and can be trusted. So how do we add logic that executes the same at each node? In our scenario, we need logic to transfer the responsibility of the product from one participant to another. We'll also need to use the data from an IoT temperature sensor to know if the temperature is too high. A decentralized application, or DApp, is an application on a distributed computing system. Typically, a DApp is built around what's called a smart contract, and smart contracts contain logic that is executed as part of the transaction and live on the blockchain. On the Ethereum blockchain network, you program the logic using a programmable language called Solidity. Smart contracts are deployed to the blockchain and are referenced by a unique address. To use a smart contract, you have to create an instance. A smart contract instance contains state data and program logic. In our scenario, a smart contract instance contains data such as the responsible participant, location, and if the product temperature is out of compliance. We can execute functions to transfer responsibility or receive temperature telemetry, for instance. When the responsibility of a product transfers to another party, a transaction is executed. Smart contract logic updates the state data. In our ice cream scenario, the ice cream factory shipping system creates a smart for a new ice cream shipment. The factory shipping system sends a transaction that's called the transfer responsibility function to transfer the responsibility of the shipment to Contoso eShipping. The blockchain network sends the transaction to all nodes, and the smart contract logic executes at each node. So what if during the shipment, the refrigeration unit fails and the temperature of the ice cream goes above freezing? An IoT temperature sensor monitors the ice cream temperature and sends transactions periodically. If the temperature is above freezing, the smart contract logic marks the shipment as non-compliant. Because the transaction is included in a chain of blocks, there is an immutable record when the shipment became non-compliant, and the ice cream shop can then refuse delivery and can avoid food safety issues. Next, let's talk about different types of blockchains. A blockchain can be public or private, and the distinction determines who can participate in the blockchain network. With a public network, anyone with internet access can join your blockchain network. No onboarding is required, and you don't have to ask anyone for permission to join. A public blockchain is decentralized with no single authority on the network. All transactions in the blockchain are visible to any node in the network. The first blockchain network was created for Bitcoin in 2009. This blockchain network is public and all transactions can be viewed by anyone, even those not part of the network. So for example, you can go to blockchain.com/explorer and look at the Bitcoin transactions back from the beginning of time of when the blockchain network started. The consensus algorithms for public blockchain use cryptocurrency as a reward to validate blocks. So the current Bitcoin reward, for example, is at 6.25 Bitcoin for validating a block and solving that block problem to have the new into that chain. So if you were to solve that problem and get that validation, by today's amount, you would get about $80,000 as a reward for validating that block. Public blockchains might also charge a cryptocurrency fee for validating transactions. So in order to participate, if you want to sell a Bitcoin, for example, there is going to be some fee that you're going to be charged likely to have that validated and to become part of the blockchain network. Public blockchain privacy is extremely limited. So if you wanted to keep your transaction private, you should only share your public key with the other participants in the transaction. And when making a transaction, you will have to share that public key. You'll have a private key that you always remain safe and not share that with anyone, since that protects your identity and also protects your crypto wallet and then your currency. So the Bitcoin blockchain network was created for the Bitcoin currency. And the primary function of the Bitcoin blockchain network was to store Bitcoin value. Value can be transferred from one participant to another in a very straightforward and easy way. Ethereum extends what Bitcoin had created by providing a protocol that could be programmable. Ethereum is also referred to as the world's programmable blockchain and allows you to really create these smart contracts and application using the Ethereum blockchain. So in addition to just simple transfers, it's really opened up the world of possibilities of all that you can do and create with the platform. With private blockchains, information stored in the blockchain is only accessible to participants invited to the blockchain network. Private networks are semi-trusted networks. In a private network, there is an agreement between all participants about how they will leverage the blockchain. A consortium blockchain is a private blockchain, but authority is distributed and acts in the best interest of the network. This, in return, makes the network less decentralized. In our scenario, we want transaction privacy from the public. So consortium blockchains restrict who has authority to participate in consensus. Trust is enforced by restricting only the participants be involved in validation. Their group of participants is called a consortium. Consensus algorithms for consortium blockchains can use authority rather than cryptocurrency. So when you're thinking of validating blocks in a private blockchain, it has to do with who has authority to do the validation. And like I said, there's not really cryptocurrency involved, so you're not getting any kind of reward. It's really all about making sure that these transactions are valid and upholding trust in the network. We may also want some privacy of data. So for example, all participants would know a product was transported, but the specific details about the shipment could be kept private. Since we use multiple shipping companies, the details about the shipments could be kept private between two of the parties. Competing shipment companies would only know that the transaction happened and could not see the details. Hyperledger and Corda are popular examples of private blockchains. Hyperledger is an umbrella project of open source blockchains and related tools to support the collaborative development of blockchain-based distributed ledgers. And Corda is a permissioned or private blockchain platform. Corda helps to ensure that data is shared only with parties who have a need to know. Blockchain technology works best for certain scenarios. You shouldn't use it as a general purpose solution. In many cases, a centralized database is a better option. So when considering using blockchain, ask yourself these questions about your scenario. First, consider participants and ask the following questions. Do you need to support multiple partners or companies? Do you want to avoid a central authority? Perhaps there is not trust in one participant, and participants may not want to be reliant on a third party. Do the participants share data or use a workflow that involves several or all of the participants? Blockchain technology guarantees that each node is consistent. Most other business-to-business solutions rely on synchronization. Synchronizing data introduces breakage and expense to systems. The consistency of the distributed data is a key advantage of blockchain technology. With performance, you might want to ask, is your transaction throughput low? So depending on the blockchain protocol and consensus mechanism, transaction rates can be low. Is there defined business logic when interacting with other business partners? Executing business logic in a transaction can affect performance. With business logic, you want to ask, is your business logic simple? Executing a complex smart contract function on a public blockchain requires more cryptocurrency than a simple one. Another question is your business logic static and doesn't change? Since blockchain data is immutable, smart contract logic changes require you to deploy a new contract to a new app. Consider how you'll version your business logic if there are constant changes to the logic. With trust, you want to ask, is trust and integrity required between participants? Does the order of transactions matter? And do you need transaction privacy? Consider the following based on the questions that I've shared and ask them as you're considering a blockchain solution, and think about how blockchain technology works and how that can be beneficial to your business to make the best decision. Also start to think and brainstorm about what are some examples that you think might be best for blockchain and what are some examples of what you think wouldn't be so great. I also want to take a moment to call out Azure solutions for blockchain. So if you visit azure.microsoft.com/solutions/blockchain, there you'll find information for the 3 primary blockchain solutions provided by Microsoft Azure. There is the Azure Blockchain Development Kit, which is going to help you simplify how you create, build, and deploy smart contracts on Ethereum ledgers. This is a solution I find myself using very often in Visual Studio Code as I am writing smart contracts and different applications. It's really helped me to stay in there in the context and kind of do everything I need to build, compile, test my smart contracts and applications from within the Visual Studio Code environment. The Azure Blockchain Service is going to allow you to manage, monitor activity, and expand consortium blockchain networks. So this is, in fact, for private consortium networks, but it is a great service at helping you kind of manage all of the transactions and activity that's happening on that network in a central place. And finally, the Azure Blockchain Workbench is going to allow you to easily prototype blockchain apps in the cloud. So this is a great solution to explore if you want to get more familiar with building applications around your smart contract logic. All of these solutions do require you to have an Azure account, so you need to definitely have that if you want to check this out. Don't forget that you can get free Azure credit when you sign up if you would like to explore any of these. Finally, I just want to say thank you for listening. I hope that you learned something new about blockchain today and are excited to explore whether or not blockchain technology can be right for your business solutions. I have left my contact information here, so please get in touch on Twitter, LinkedIn, or via email if you have any questions or want to chat about blockchain. Thank you so much. Again, I'm Meaghan Lewis. Cheers.